All right, hello everybody, and welcome to the stream. I hope everybody's doing great tonight. Spiro, starting off with the 5 gifted community subs. I really appreciate that. Thank you, buddy. Welcome. And how are you doing? I appreciate that support. That means a lot. Thank you. Heck of a way to start off the stream. um, so yeah, I hope everybody's doing well tonight. We're going to pick up where we left off last night, and we're also going to tackle something new tonight as well. Something that's also been on the to-do list for a while. So we're kind of trying to clean up that to-do list a little bit. So before I get into it, I do want to take just a quick second and thank the supporters of the channel, starting with the partners, who are the highest tier of subscription over on Patreon and YouTube memberships. They are Gebi Bashir and Gabroli's Inc. I'd also like to thank all the other supporters here that are listed under the supporters section. They are a combination of Twitch subscriptions, the other tiers of Patreon and YouTube memberships. So thank you all very much for your support. It means a lot, and I greatly appreciate it. Of course, I appreciate all the viewers, whether it's on the YouTube side or whether it's on the Twitch side. I do have both chats open on separate monitors here, so I can see you guys. And so I appreciate all of you guys here. Without all of you, this project would not exist. So I thank you guys very much for that. Okay. Smudge, good to see you. How's it going? Hope you're doing well. Tammin, good to see you too. I was official. Good. Hello, good to see you as well. And over on the YouTube side, Don Developers, good to see you as well. How are you doing tonight? Hope you're doing well. Okay, so I actually started kind of adding a few things. I did a few things off camera right before the stream, and I did, some of these things, just kind of trying to move things forward a little bit. So a couple of things that I did was I added a new k-deprecated macro. And that allows me to mark things in the code base as deprecated, which we're actually going to need, because there are things I want to deprecate in this version and then remove in the next version. And that's just because 0.7 has already got a lot going into it, and I've actually started moving stuff out into 0.8, just because it's kind of a massive set of changes that are going into this version, right? And so one of the things that I marked as deprecated was the geometry functions in the render API, because I don't really want the renderer to know anything about geometry. It should really know really just about vertex and index data, right? And that's about it. Buffer offsets, things of that nature. It doesn't really need to know about geometry as a whole, right? So we have entry points for all those other things. And I want to get rid of the geometry ones. That'll clean that interface up a little bit. We also combined geometry utils and the geometry type into just a geometry H. And then I made a small enhancement to DRA pop and DRA pop at, where the destination parameter for the popped element is optional. So if you pass 0 or null, it now doesn't actually perform that copy, right? So there's a lot of cases where we actually pop something off of a DRA and we don't actually care about that value anymore. We're just going to throw it out anyways. And so we've cleaned up that interface to no longer require that. And then I also did some cleanup on assertions to actually stop the application when an assertion fails. So those are some of the things that I did off camera, and then we actually started kind of exploring a little bit on how we're going to standardize our plugins, and that's what I really want to tackle tonight. All right, Scary Hutman, how's it going? Good to see you. Thank you for the posture check redeem. I appreciate that, and the stretch redeem. Thank you. I will do both of those as my elbow pops really loudly. General Kenobi. I love it. All right. So, last night we were sort of in the middle of, moving some things around and whatnot. And I did a little bit more of that today. And I could step through it, but I think it would just take longer than frankly it's worth. So basically, I spent a little bit of time just fixing bugs that had come up from that, and all the file moving around and stuff like that. So I'm not really going to go into that. What I want to tackle is our discussion of plugins. So if we take a look at our plugins, right, we have 3 plugin libraries right now. We have our audio OpenAL plugin, right? We have our render Vulkan plugin, and we have our UI standard plugin, or our standard UI, right? And all 3 of these plugins currently inject themselves in different ways into the code base. And there's also this kind of ugly system that we have that currently the application is responsible for, that it really shouldn't be. So we want to offload that off from the application and have a sort of standard entry path for all these plugins, and also have sort of a standard interface, if you will, for all these plugins to get their hooks into the engine, and then a system to manage the memory of those things, manage the life cycle of those things, and so forth and so on. And so that is another thing that we're going to tackle. We're going to create a plugin system that will do all of that for us. So when we talk about plugin, we should probably talk about, what is a plugin, what is its scope, and what all does it need to hook into? And of course, that varies by the plugin itself, right? So for example, our audio plugin doesn't need a render hook, but it does need an update, right? Whereas our render hook doesn't necessarily need an update, but it needs a render hook and a frame prepare hook, right? And so those are kind of the different things that we need to think about when we're actually making our plugin system extensible, right? So there are certain things that we should make optional. There are certain things we should make required. And I think the required bits are actually going to be pretty small. And then it's up to the plugin itself to actually hook into what it needs. And by using this sort of opt-in type of logic, the plugin can really drive how it works instead of it being driven by, engine requirements and so forth. Okay, so let me see. RCW, good to see you. How's it going? Reading DRA.c right now and got a question. Don't want to derail your current topic though. So I would say put the question in chat and I'll get to it when I can. All right, so let me actually get rid of this other pane over here. So currently, the way that these work is actually 2 of our plugins have this sort of plugin main, more or less, right? So the audio plugin has that, and the Vulkan renderer plugin has that. And then they contain source, off, on their own as well. And then our standard UI does not actually have, well, I mean, it does because we kind of created one, but it did not have that before. And now we're going to fill that out. So what I'm thinking in terms of the life cycle of a plugin is we're going to configure our application to, or allow our application to configure, rather, what plugins it should load. And we're probably going to use a KSIN file to do that, is what I'm thinking. But the idea is that we should be able to configure that almost with no code at all. If it's possible to do, I'd like to configure it with no code whatsoever. A plugin should know how to sort of strap itself into the engine and handle what it needs to handle. It really shouldn't be relying on the application to do that. If the application needs to link with it, to interface with it, that's fine. But the application should not be driving how that plugin works, more or less. So, DWoo38, thank you for the follow. Appreciate that. Singy, hello. Good to see you over there on the YouTube side. And so, when we talk about the... Oh, DWoo, thank you for the Prime sub. I appreciate that support. That means a lot. Thank you very much. When we talk about the plugin's lifecycle, I like to think of it in sort of stages, right? So we have an initial stage where the plugin is created, right? And then that's basically where we set up things like function pointers. We set up, maybe we allocate a little bit of memory for the for the plugin state, things like that. But we don't actually allocate any resources or anything like that. So that happens very early on in the application's boot up stage. In fact, probably even before the application boots up, right? The application can tell the engine, hey, I'm going to use these plugins, by the way. And the engine can then very early on say, okay, these are the plugins I'm going to be aware of. We'll stand them up later. Fast forward a little bit in time. We'll have an initialization stage, and that's actually the first thing that we see here in this K runtime plugin. And so I'll touch on this struct in just a second, but the first thing that we have is an initialization stage, and that is basically where we start to stand up any resources that we need if they're required. So for the graphics API, that might be setting up like our Vulkan instance and things like that, right? So that's where we do all of that kind of thing. And then obviously destroy is when the plugin gets shut down, right? Or when we're done with it, we don't need it loaded anymore. So that's sort of the end of the life cycle of the plugin. And then everything else, and as far as like plugin hooks, really have to deal with the individual frame of the game loop as a whole. So we have a hook for the update phase. We have a hook for the frame prepare phase. We have a hook for the render phase. And then we also have maybe some events that we'll hook into. One that I know we're going to need that we don't really even need the event system for is handling window resizes, right? We just want to sort of provide that hook to the plugin right off the bat because there's probably a lot of plugins that are going to need that, right? The Vulkan plugin needs it. The standard UI needs it. And there may be others as well once we start extending things, right? So that one, for example, is definitely one that we want to provide. The other thing that a plugin will need is some sort of state, right? And it's up to the plugin what kind of state that is, what data it needs to hold in its state. But we need a block of memory for that, right? So we've sort of forward declared this structure like a runtime plugin state, right? And that is basically what's going to hold that. And then we have a size that goes along with that. So the idea is when we create a plugin, the first thing that we're going to figure out is how much memory do we need for our state. That's the very first thing that we figure out. The other thing that we're going to figure out is when we're actually standing that up, which of these hooks do we actually utilize? Which of these hooks does the plugin actually need, right? And it's up to the plugin to actually provide those hooks if need be. And we'll kind of get into how we're going to do that in a bit. And then from there, we just kind of build out the plugin as is. And so once the plugin is actually created, it will be registered within the plugin system that we have to build. And that plugin system will have hooks into these various portions of the frame, etc. It'll also receive some of these events. And we can always extend this later, but that's the general idea, right? And so all of this is going to be encapsulated under a structure that's called a K runtime plugin. And that contains, obviously, the name of the plugin, all of these different hooks, as well as the state of the plugin, okay? And so, actually, I just noticed a naming inconsistency here. This should be a K runtime plugin. And this should be K runtime plugin. So, why are we calling it a K runtime plugin? Well, that's because our plugin system is going to live in the runtime, right, in the kohi runtime. So it makes sense that since that's where that plugin is going to live, that's what we call it. Now, we may have other plugin systems that we set up, like our editor is probably also going to have its plugin system, but that'll have a different set of hooks. That'll have a different set of, a different way of being instantiated, right? So it doesn't necessarily make sense to try and be that generic with it. So we're going to start with a runtime plugin system. And I just put the K for kohi in front of it, right? And that's where we're going to start with that. So I hope all that makes sense. Let's see. Okay, your allocate array using K allocate of size, header size plus array size. So basically the array items get added just behind the array header. That's correct. But as far as I know, this causes alignment errors. For example, if padding bits bytes would be inserted between the last header elements and the first array item. So no. So we actually handle alignment outside of that context, right? So when we perform memory alignment, if we're aligning that D array, we're aligning that whole contiguous block of memory, right? We're aligning the header and then the array immediately after it, right? And that's the reason we put the header first, because that's always going to be a fixed size, which I think is 24 bytes off the top of my head. It's either 24 or 32, I can't remember. But we, actually, I think it's more than that. I think it's 36? I don't know. I'd have to look. But anyways, that header is always going to be a fixed size, right? And then immediately after that, we have that block of memory. But it's all one contiguous block. So if we need to pad any of it for alignment, it's always going to be padded at the beginning of that array, right? And if you're worried about the array elements themselves not being padded out, I think because of the size of the... You know what? Let me look at it instead of trying to guess. So let's see. This will automatically be aligned. Right? Okay, so we have 8 bytes, 8 bytes, 8 bytes, 8 bytes. So, yeah, there's not going to be an alignment issue there. Because it's any padding would come before the D array header, right? So if the D array header is aligned, so too is the memory that comes after it, if that makes sense. Don't worry about your English. Your English is just fine. I'm totally able to interpret it. Yeah, don't worry about that. Let's see. Isn't it better to provide a general event listener for the plugin, and the plugin itself hooks into the events it needs? So we're going to have that as well. It's just the resize is one that I'm sure a lot of plugins are going to need. So we're specifically handling that one just to avoid having to go through the event system. But it can hook into events just like anything else can, because events are part of the runtime, right? So in the runtime, events are here, right? So our core library can't use events, and nor should it really be. But our runtime and our plugins, which also reference the runtime, can use that, right? So they can certainly hook into it. It's just that's a common enough event that is going to need to be handled by our plugins that I'm just handling that one specifically. Yeah, so to your point, the renderer in UI needs a resize event, but audio doesn't. So audio just doesn't implement that function. That's it. Is literally all it is. So instead of on resize, provide a non-event method. Yeah, so I could do it that way, right? And there's nothing wrong with doing it that way. It's just a little bit of a special case because I know that most of our plugins are going to need that. So it's literally going to be a thing where the function essentially has to have a specific name, and then we'll try to use get proc address on it. And if that doesn't work, then it's considered not implemented for that plugin. And then whenever we go to distribute that event to plugins, it'll say, well, do we have a handler for this? If not, then don't do anything. If we do, then pass it on. Isn't stride the size of the elements? No, stride is just it's just the U64, right? Which is almost always going to be too big, right? But like it's not the actual stride, it's just a number that represents how big the stride is. So it's more or less, actually, this comment needs to be updated, but this comment kind of describes what it is, right? So, void pointer, allocator, if used, right? Otherwise, 0, right? So, you know, this is 8 bytes, right? That's 8 bytes. That's 8 bytes, and this is also 8 bytes, right? Even if it's a null pointer, right, it still represents 8 bytes. So all of these things are 8 bytes apiece. Bear in mind, this is not this is not a header per item. This is a header for the entire array. No, this is always here. So this allocator is always here. Even if it's not used, that memory is still taken. But this entire, whoops. So what did I do? Hit the wrong button. So this right here always exists no matter what. And it's for the entire array. It's not like it's per element, right? So you're always going to have that there, no matter what. Like even this last element, like even if the allocator is not used, it still represents 8 bytes, right? Because it's a pointer to nothing. But it's still there, right? So this header is always going to be what basically our alignment happens before this header, right? Since this is 4 8-byte blocks of memory, and the elements come directly after that, the elements are automatically aligned as well. I hope that makes sense. Wait. But if the elements need 32 bytes, they're misaligned. If the elements need... Wait. If 32 bytes is needed by a single element because it's a big struct or something, or 64 per element, if the header is 32, it's still irrelevant. Like, I have not seen alignment on arrays be over 16 for anything in terms of requirements. But regardless, I mean, if we do have a 64, well, okay. So 32 byte elements would be fine. 64, well, I guess anything larger than that would have to be padded out to 64, right? If your alignment requirement is 64, which I've not seen an alignment requirement of 64. But yeah, 32 just kind of lines up naturally nice, right? And then if your elements themselves have to be aligned to something, then it's kind of up to you to make a struct that's going to achieve that alignment for you. I'm certainly not doing that in here. That'd be way too much overhead to try and consider in here. This is off the point, but constant buffers in Direct3D12 are 256 byte aligned. Yes. NVIDIA and Vulkan requires that too for uniform buffers, but I wouldn't use a D array for that, right? You're uploading that to the GPU, so I wouldn't use a D array for that. x86 is super lax about alignments compared to other things. That's true. But you know, there are certain things like anything that's being uploaded to the GPU, I wouldn't use a D array for that probably. Like uniform buffer stuff, I don't use. I just allocate a block of memory and I perform that alignment myself as I'm uploading the data to the buffer. So, to that effect, we're fine, right? Because I've actually tested this on an NVIDIA card that requires 256 byte alignment. So I do know it works. Okay. Oh, thank you for the hydrate, Redeem. Appreciate that. All right. So we have this sort of defined. We need to look at our plugin system, which I kind of put some notes here on how I want to handle that. So we want to build up a system that can load plugins by configured names. which it then uses to load shared libraries. It will then load up the found k-runtime plugin functions that are available, set up the state, register it as globally available to be queried later. This should happen early in the boot up process so that systems that have backend plugins like audio and the renderer have what they need by init time. So that's more or less the requirement for it, right? It's relaxed, but sometimes unalignment can lead to performance penalty. Exactly. So I try to, I mean, as far as like my vertex and index data, that's all, that stuff's all aligned. I make sure of that. Just because I don't want to pay that performance penalty, right? I know there's a few places where, I've got to fix some alignment things, but for the most part, we have aligned what we need aligned. And when I go to put in SIMD, that will really expose a lot of things too. Right, so I know there's some things around matrices that we could definitely gain performance from that, but for right now, it's not a huge deal. Okay, so plugin system. So the first thing that we need to do is we need a exported KAPI. Actually, do we need to export this? We don't need to export this one because it's in the runtime. And actually, should I put this in systems? I probably should put this in systems. Let's put this down here with the rest of the systems. Even though it's for plugins, right? I might actually move that types to somewhere else. Right, so we need plugins, plugin types, and then we need a, I'm not going to export this because it's only should really be stood up within the engine. So we'll do B8, plugin, system, initialize. So we need a U64 pointer memory requirement, right? We're going to follow the same pattern that we've used elsewhere. We need to forward declare struct plugin system state. We use that struct here. Plugin system states pointer state, and then configuration. I don't know that we're going to need any configuration for this, but I'll go ahead and forward declare something anyways. Plugin system config, and this will be a struct plugin system config, and we'll call that config. All right. Oh, I'm in the H file. What am I doing? All right, so that's our initialize, and then that's going to follow the whole call it twice pattern once to get the memory requirement, and a second time after the state has been, or the state block of memory has been allocated, it will then call it again with the state and actually set the thing up. So we'll also have a void plugin system shutdown, and that's going to take a struct plugin system state, and then we're going to have various hooks into various parts of the engine, right? So we did say we needed update, so I'm going to do, I guess I can make this return a B8 plugin system. We're going to have ads here in a second. Update, and we're going to say struct plugin system state, and then we also need up here we need to forward declare struct frame data, so we're going to need that as well. So struct frame data p frame data. All right, so that should handle the updates. And before we go too much further, I do want to mention that we do pause the channel or the stream for ads when they come up. So on Twitch, we are served every 30 minutes with up to 90 seconds of ads. So we just like to pause the stream so that nobody misses any content. I know over on the YouTube side, things work a little differently for you guys over there, but to keep the playing field even, we have ads. And that's what we do, right? I did fix the timer, by the way, so there's that too. Finally finished that. And I do like to encourage people also during the ad break to hydrate. So if you don't have water, go get water. Hydrate. It's important. You're allowed to drink water now. Nice. Okay. So we got about a little less than a minute left on ads, and then we can continue. As it turned out, by the way, I did actually have the script fixed last night, but I had to relaunch OBS for it to take effect, so I couldn't have fixed it on stream anyways. All right, we got about 30 seconds left on ads. All right. And ads are done. So, hang on one second. Oh, the cat threw up?
No, she's curled up in the hallway with her satchel.
Oh, curled up. I misheard what you said. Okay. Thank you. My wife just made strawberry cobbler is the word I'm looking for. It's awesome. Thank you. Okay. So, is there a breakdown somewhere of why you chose C over other languages? Mostly it is preference, but language simplicity, compilation speed. I don't use most of the features of C++. I don't use OOP, things like that. So those are my primary reasons, right? Just to kind of give a quick overview, right? New to all this game dev, so I have no opinions yet, just curious. And that's fine. Yeah, like I said, mostly it's preference, right? I do have some technical reasons behind it, but mostly it's preference. I found when I was writing C++ code that my C++ looked a lot like C anyways, because I don't like using a language where you're supposed to manage your memory and then having the language manage your memory for you. Like, if I wanted to have my language manage my memory for me, I'd use something better than C++, right? C++ makes me sad. Yeah, agreed. Tim, you're writing your engine in C++? No, I mean, to each their own, right? I'm not going to poo-poo it, but to each their own. It has a lot of, it's an industry standard for a reason, right? Can you share a link, or is that not allowed here? So my bot usually blocks links. I guess you could try it real quick, but I think my bot's going to get rid of it. But if you have a link, you could hop on the Discord server and drop it in there in the kohi channel, and I'll see it. What's your opinion regarding typedef versus struct? Some prefer struct because it makes code more readable, but typedef is shorter. You mean typing struct everywhere? I hate typing struct everywhere. That's why I do that. Like, obviously, like, these are for declarations, so that's something different, but like... Oh, you're saying arrays versus structs. They have different uses, right? Yeah, they're completely different things. Now, if you're talking about structure of arrays versus array of structures, that's a different conversation altogether. So I'm not sure if that's what you mean. Oh, it was a whole stream bicker for you with your chat, Spiro? A hot argument? Really? Over what, pray tell? That's curious to me, because they have different, like, they're different things, right? The only thing you use in C++ are namespaces and templates sometimes. Yeah, see, I avoid templates like the plague. So why do you hate typedef and prefer struct? I don't. I just think they have different uses. So in Zeg, structs are more performant under the hood if you use structs for a variety of data types. But for data of the same type, arrays are more performant. Depends on what you're doing. Again, though, right? Like, chat didn't agree and you proved them wrong. Yeah, that's awesome. Yeah, I mean, like again, it depends on what you're doing, right? That's why data-oriented programming is a thing. Do you have an array of structs or a structure of arrays? Yeah, like it's documented and proven. That's hilarious. If all else fails, profile it, right? Okay. So we have our update hook, and actually our next two are going to be almost the same thing. So we have a frame prepare and a render. And then we also have a window resize, which again I'm handling directly because that's a common enough thing that I don't want to have to rely on the event system for that. We can kind of short circuit that one, and we may add more of those, right? I think most things, I mean, technically this would be fine going through the event system as well. But this would just be an example of a different way that we could add a different entry point into our plugins. So instead of render, this would be, I guess we say on window resize. And instead of this, we would do, I think we had U16 for width and height. So we have that. Also, we need one more forward declaration of K window. Right? Because struct K window. Oh, you know what? We have a naming thing here, it looks like. So it looks like I have it with and without the underscore, which I think most things I've actually done has been without the underscore. So I think I might actually have to go fix that. Only in 29 places, but most of them are in platform, so that's not a big deal, I guess. So let me do a K underscore window and replace that with K window and do that globally. All right, and then go to, didn't I just do platform H? Oh, K window config. Right. Okay. And platform Win32. Also, all these platform changes I'm going to have to do on the other platform layers as well. So that's going to be fun. Okay. And good. Got them all. All right. So at least that is consistent now. Why is that bleating about the declaration of that? Did we not forward declare that? I thought we did. Guess we didn't. Okay. Window. Okay. So we've got that. And let's see. We have initialize, shutdown, update, frame prepare, render, and resize. I think that's all of our entry points. So these are going to be all called from various points in the engine. And then the engine is going to call these, and then this system will then pass those on to any plugins that have been registered. So I think the next thing we need to do is a register of a plugin, right? Registry of a plugin. So when we register a plugin, I'm thinking we really should only be having to provide as minimal information about that plugin as possible. So maybe we provide like a name of the shared DLL that it has to load. And then it'll load that and automatically reach into it using get proc address or some similar to get the function pointers to what it needs. And then it should be able to take it from there. So we need a name and then maybe some optional configuration to pass to the plugin when it's initializing. And I'm thinking that configuration should probably be a string. And the reason I'm thinking that is because more than likely we can set up our plugin configuration to be a KSIN file, which could then contain any sort of configuration that we would need. And we would essentially read the contents of that file and pass it off to the plugin as a string and let the plugin deserialize it as it needs to. Oh, line 18, I have a foobar. Oh yeah, you're right. Dyslexia strikes again. Thank you. Okay. So we need a way to register. So I'm going to export this one. And let's have it return a Boolean just in case it fails for some reason. We'll say plugin system register. Should we say register? Why don't we just say load plugin? Right. And let's see. We are going to need the plugin state in order to achieve this. Which I guess we could then retrieve. We could retrieve that from the engine, because I actually added some spots to do that. So let's say struct plugin system state and then we'll do a constant string, and we'll say name, and then another constant stream config. I think that's perfectly acceptable. Right? And the config could technically be null if we don't need anything. Or it could actually be a string that we pass. And that could technically be any format, right? It could be up to the plugin what format it actually wants to use and parse to. So that would actually be another strong point of using string as the configuration. Okay. So the only part where the name is going to matter is where we initially stand up the plugin and actually use that to load. So let's go ahead and start laying out the C file. So we'll do plugin system C. Right, and we want to include plugin system. Paste all these things. Right, so we'll do that. So we'll start with the initialize. So actually we need to start off with the type def of the actual plugin system state. So let's do type def struct plugin system state. And we'll also need, I think we might already have plugin types. I'll include it here anyways. Include plugins, plugin types. And we're essentially going to have, our registry is going to be just an array for right now, I think, of plugins. If we need something more advanced than that later on, I think we can add that without too much trouble. But for right now, let's keep it a simple flat array. So we'll say k runtime plugin, and we're going to have an array of those, and we're going to call it, I guess we'll just call it plugins. Whatever, it's fine. And this is going to be a D array, so that we don't have to worry about realix or anything like that. Makes it nice and simple. So we'll include containers D array. All right, and for now that's going to be it. So what we'll do here is we'll say first off, if not memory requirement, then you done messed up a run, and we're going to return false. Otherwise, we're going to say the dereference, or the value of memory requirement, is going to be equal to the size of plugin system state. Whoops. System state, right? So we have that, and then if state is not passed, we're going to return true, right? Because that means that all we were doing here was just gathering the memory requirement, and then we can allocate this thing externally and call it again, passing that through, right? So here it's going to be assumed that we actually have that state, and so now we can actually set that up. So we can say state, if I can spell it right, plugins equals darray create. We're just going to create that with standard allocation, and we're going to say k runtime plugin as the type. And for right now, I think that's actually it. We may need to actually do some more stuff in the future, but that's going to take care of that for right now. Miss Demonizer, thank you for the follow. Appreciate that. Summon plugin. Yeah, there you go. I like that. I should say summon plugin. That would be funny. Where are you using if not defined instead of pragma once, because it's an old habit. And also, I'm at some point, either during this reorg or very soon after, I'm actually going to see how far back I can be compatible. I'd like to see if I can do C99. If I can't, it's going to probably be like C11, but I want to see if I can get it compatible with C99, just because. I told you. Yeah, exactly. Because why not, right? More than likely, I'm going to stick with C11, but I definitely don't want to be using any of this, new C version stuff, because I don't know that that's going to compile on every platform, because I eventually want to support consoles with this, and that's certainly not going to work, right? All right. Sounds like a great fun challenge. Once you start, you may end up at C89. Oof. Yeah, I don't know if I'm going to go back that far. It depends on how much I hate myself, I guess. Going back to C89. That might be a bit too far back at this point. I think 99 is a reasonable goal. I think where I'm going to wind up is probably on 11, but we'll see. All right, so plugin system shutdown. So if we have a state, we are going to want to, first off, check that we have plugins. So if state plugins, then we're going to say U32 plugin counts equals darray length state plugins. For U32, I equals 0, I is less than plugin count plus I. And then I guess what we'll do is plugin shutdown, right? So we'll do let me think about this for a minute. Actually, it should be plugin destroy. I think that makes sense. So let's do k runtime plugin equals the address of state plugins sub I, and then if plugin guess we'll do destroy. So if it has destroy, which it should, but we'll check it anyways, then we'll call plugin destroy. And I believe it just wants the plugin as its only argument. Yes. So we'll do plugin. Right? So we'll destroy all the plugins. And then darray destroy state plugins, and then state plugins equals 0, just for good measure. Right. So we should be good there. I think we already lost C89 for sure. Yeah. Yeah, exactly. That's the thing. Yeah. C89 is just not something I'm interested in supporting. I don't want to go back that far. Because that one requires that you do all the variable declaration at the top, if I remember correctly. So, yeah. I don't do that anywhere in the code base. So, yeah, that's already not going to be a thing. Yeah. Okay, so we destroy all the plugins. I don't think there's anything else we need to do there, so we can move on. All right, so we are going to basically need, though, this loop a few more times. So for the updates, I guess we could probably combine these two. right? Right. So we can say if we have the state and we have plugins, loop through them. And then if the plugin has update, then we want to do the update. Right. And the update, I believe, also requires the frame data. So we'll do p frame data. Okay. Now, these can potentially fail. Right? I believe, yeah, returns a Boolean. So, if anywhere along the way, one of these fails, we are going to bleat about it. Plugin failed update. And we'll say the name of the plugin. So we'll do plugin name. Right. We'll also say C logs for details. Now, I don't think I want to shut down. I don't want to like abort the entire like plugin system update if one fails. I think just bleeding about it is fine. So I'm not gonna like return false there and just quit if one of these fails. I think we don't want our system to be that fragile with plugins, right? So what we can do is at this point, after we've proceeded through them all, we'll return true. And if this is called, oh, you know what? Let's just return true down here, actually. And then if we need to modify that, we can. So this is what we're going to want to go with for frame prepare. Right? And these are basically just called, it's like the same logic that runs for all of these. They're just called at different points, right? So this is going to be frame prepare, and then we'll do frame prepare here again. Whoops. Frame prepare. Whoops. All right. So again, we're not gonna like fail the entire loop if one of those things fails, right? Just move on. And then we have render, right? So it's pretty much the same stuff all the way down. Render. Okay. So it only calls it if it actually has it set up. And again, actually, same thing is going to be for window resize. Right, so these all look pretty much the same. They all pretty much are the same. I suppose we could like make a macro or something so this isn't quite as repetitive, but we may have to tweak some of these along the way. So I don't necessarily want to do that just yet. So instead of plugin render, this is going to be plugin on window resized. And then instead of frame data, we're going to have window width and height. And then failed on window resized. Actually, does that? I don't think that does return Boolean. So this one's actually going to be different. Yeah, it does not. So that one is just going to be a straight up. Oops. That one is going to be a straight up function call, and that's it. All right. So we just pass that one on. And then load plugin is where all the magic happens. So first we'll check to see if we have state. And if we don't have state, we're going to return, return false. Because what are you doing if you don't have state yet? Also, if we don't have a name, then we're going to say kerr plugin system load plugin requires a name. Return false. And return ads, because we have those too. Yeah, prototypes, exactly. Yep. All right. Bad Comic, how's it going? Good to see you. Is there much difference between designing a plugin system and a modding API? Yes, there is, actually. So I'll answer that. I'll answer that once we get done with ads, actually. It's a good question. You got here just in time for ads. Perfect. It's the best time to get here. Thank you for the resub, Psycho.
Ads.
NVM screw ads. I appreciate that. Thank you for the support. All right, we're almost done with ads. All right, cool. Ads are done. Oh, so yeah, Sidecode, thank you. Sidecode, thank you for the resub. I appreciate that. 8 long live chaos Twitch scam. That's one hell of a username. Thank you for the follow. Glad to support. I really appreciate that, Sidecode. Thank you. Definitely appreciate that. So there's a question from the YouTube side that says, is there much difference between designing a plugin system and a modding API? Yes. So plugin system is basically designed for an external library to be loaded and to operate through certain hooks within the application and respond to events and things like that. Which is a little bit different from a modding API, because a modding API is typically more like a scripting language interface where it exposes a bunch of different functions and variables and other pieces of data to some external script or library that runs against it. So there is a little bit of difference there. But you could argue that they are somewhat interchangeable as well. There's a lot of overlap between the two as well. So, yes and no is the answer to that one. Hello, just a quick question. What's the current state of this engine? New to your channel. What is and isn't done? Also, what are your plans right now? Okay, so I can quickly review that. I'll give you a quick snapshot of what the project is about and where we kind of currently stand. So, we have this website here, which is kohiengine.com. I'll drop a link on both sides of the chat. So what we're developing is a game engine from scratch as an external, or as an educational, rather, exercise. And so it started off as a YouTube tutorial series on, just kind of going step by step with a lot of hand-holding and stuff like that in the beginning. And we changed formats a few times as we went along, and basically we wound up into this sort of live coding format that we're in now here on Twitch, and of course also on YouTube. And so the project's been underway for about 3 years. I do this in my spare time, and so I only work on it part-time at best. But it has been going on for quite a while, and we do have quite a bit done. We're almost to the point where we're going to be able to make our first simple game with it here very shortly. Excuse me. So just a little bit about the engine itself. It is cross-platform, meaning it works on Windows, Linux, and Mac OS. We have other platforms planned for the near future after that. Mainly iOS and Android are on that list. and eventually consoles. It is open source and free. So if we come down here, we've got links to like YouTube, Twitch. We have a Discord server that's got about 900 people on it. And then we also have, Patreon links, things like that. But if you click on this GitHub link, it'll take you to the repo, right? So this is completely open source. It is Apache 2.0 license, which means if you use the engine, all that I ask is that you say you used it. That's it. There will never be any licensing fees or royalties of any kind. It's 100% free, always will be. I don't paywall anything on the Twitch channel. I don't paywall anything on my YouTube channel at all. All of the support there is purely to support the project, and me directly. It doesn't actually buy you anything, right? I don't accept my appreciation, I guess, right? I don't paywall anything because I believe educational resources should be free, and that is what I'm doing here. So it's all free. We have, with that said, we have a to-do list that I maintain, and I'm constantly updating this thing, which has an entire list of items that we've done and haven't done. So everything that has an X on it is done. Everything that is blank, like this allocators here, might have a sub-item that's not done. And so we have a bunch of pieces of this working. We have the ability to load scenes. We have our custom formats for our geometry. We actually implemented our own storage formats, sort of like a light scripting language, if you will. And so I'm just going to scroll through this very quickly because it is the to-do file that's available on the repo if you want to look at it more in detail. But we do have quite a few things that are in place. And there's quite a few things that we need to do as well. Not all of these are needed for the first game that we're going to do. So all of that up there was all of the engine generic stuff. We also have a bunch of renderer tasks here to do. A lot of which are already done. We also have plugins that we need to do some work on. So right now, the Vulkan renderer is our only renderer backend for right now, but that's not going to be the case in the future. We're also going to support Direct3D and Metal and potentially OpenGL. I haven't decided on that one yet. And so those are coming in the future with multi-threading for some of them. And we also have our own UI system, which we're starting to kind of build out. And then we're going to have an editor with a obviously much longer list of things to do than this. But this is just sort of the stuff I could think of off the top of my head. And then some other things that we need to do here that are to-dos. So if you want a overall snapshot of where the engine is, this is kind of where it's at. One other thing I could show you, since the engine doesn't currently run, because I'm in the middle of a pretty large refactor right now, is we do have some screenshots on the repo as well. So we do have a PBR pipeline that's running. It's not 100% complete yet, but there's still some features we need to add there. But, it is starting to kind of look pretty good, I think. And so, yeah, we have a lot of information here in the README, and then obviously throughout the repo itself. So I hope that answers your question. Okay. Thanks for the answer. I appreciate it. Awesome. Also seem rather familiar. Were you a dev at some big company? I also saw that you're doing PBR lighting. Any plans to leverage Vulkan and RTX cards for ray tracing? Okay, so that's a loaded question. I'll take that one bit at a time. Were you a dev at some big company? I've worked at a few large companies, eBay being the biggest one, right, which isn't game dev, but I have worked at a game dev studio as well. But nothing like AAA, if that's what you mean. So, but I have been around on YouTube for a while, so maybe that's it. Any plans to leverage Vulkan and RTX cards for ray tracing? So ray tracing is something that I have in mind for the future. I'm not going to be getting to it anytime soon just because that's purely a rendering thing. And there are lots of other features that we can knock out that aren't even renderer specific that we need to actually knock out first, right? Like physics for one. So yeah, lots of plans. We do maintain a to-do list, and I'm constantly adding things to it and crossing stuff off. And this thing is living, breathing document, very much so. And right now we are just building out a sort of official plugin system that our 3 plugins that we have are going to implement and use. Because right now they all sort of have their own way of getting their hooks into the engine, and that's not really what we want, right? Is CSG something still worth implementing in a world editor? Seems like a lot of editors have moved away from that workflow. I think they are. I want to implement one. I don't know why a lot of people are moving away from that. I don't know. I've always thought it was a really cool system. I'd like to implement it for sure. Nowadays, people like to just, take their high poly meshes straight out of Blender or Max or Maya or whatever and slam it right into Nanite and call it a day. But, yeah, I'm not about that lifestyle, so... we're going to explore many different tool sets in terms of how we're going to build games. And CSG is one of those things I want to implement. I've never implemented a CSG system before, so that's going to be an interesting exercise. Let's see. Gnarly Quack, good to see you. We're almost ready to draw a triangle with Vulkan. Yeah, thankfully we're way past that. Don't be silly, it will take years to get that triangle going. Probably in metal, anyway, yeah, when I get to that point. 3 years in, I think the light at the end of the tunnel is visible. Nice. Maybe we'll get a red one soon. Yeah, maybe. Never know. Never know. Okay, so, loading the plugin. One thing that I want to do is I want to reference the current way that we're doing this, which is going to be testbed entry, I think it was. Yeah. Which is obviously all broken because we're refactoring stuff, and that's fine. So this is the way that it works right now. Is our application is currently responsible for dynamically loading the game library. And then we have like all of these, this is fine for like the game library itself, but like plugins are also handled this way, right? And I'd really like to actually get away from having this logic in the application too, right? I'd like to standardize this as well, which actually, let me add that to my to-do list. Let's see, let's put that here. Plugin system implementation. Let's move that down here. We'll add a new item. And we're going to say move loading of application lib from app to engine. Config powered. Right, we want that to be config powered, just so I don't lose track of that, right? Because we want to get all this kind of crap out of the application, right? We don't want when you set up an application, we don't want you to have to do all this stuff. Like this was fine to get it up and running, but like this is not the way we want to be doing this. And also our game hot reloading is implemented here too, and it really should not be, right? So we're gonna fix that too. But not right now. What I want to focus on right now is actually the loading of the plugins. So right here, if we take a look, we say we load the renderer plugin here. So we load the library, and then we load a function, which is this plugin creates, right? So that's where what ultimately calls like get proc address, and gives me a function pointer. So we actually already have that in our platform layer to do all that stuff for us cross-platform. So we don't have to worry about that stuff. But then we say, okay, well now we need to create the renderer plugin. And that essentially just calls plugin create and then does this renderer plugin call. If we take a look at the OpenAL plugin, again, we load the library, we load a plugin create function, and then we say create the renderer plugin, which is just this audio plugin create, right? Which is just a function pointer. So we want to get this crap out of here and over into our plugin system in a generic and standard way so that all of our plugins load the same way. You'll also notice that the Vulkan plugin is loaded here, the OpenAL audio plugin is loaded here, but the standard UI plugin is not. And that's actually loaded a different way, and that's bad. So we want to standardize that. And that is the purpose of this guy. So that is where this comes into play. So we're going to actually need include platform. I don't think we're going to need file system just yet. We might, though. Actually, we might when it comes to loading the config. Right, so we're going to load this by name, which is already kind of sort of being done here. So what I want to do is kind of follow suit here. Right? And so what we're going to do here is we're going to say load the plugin library. Right? And this is going to be name is going to be used there. And then let's see, we have out application renderer library. What was that? I think that's literally just a... Let's look at the platform layer. Let's see. Load. There it is. Let's see. Okay, so we have this dynamic library. And if we go to definition on it, we have the name, the file name, the internal data size, the internal data. So this is platform-specific stuff, right? We also start a file watcher. So anytime we load a dynamic library like this, we get a file watcher for free with it. And then we also have a dynamic library function, which is the darray of function pointers. This, I'm thinking we might do away with this. I haven't decided yet. The idea behind this is, if we take a look at the dynamic library function, it saves the name of the function off, and then the function pointer itself. So the idea is that whenever you load a function, it saves it off to this list, and then if we reload that library or hot reload that library, it automatically reloads that. So I may keep that, I may not, I haven't decided yet, but that's more or less what we want to do, right, is the load up the dynamic library. So let's see. So we want to go here, and we don't have a renderer library, right? So I guess that means we actually really need something added to our plugin state, right? Because I guess we could reasonably add that to our plugin state. So let me go to plugin types. And so we have our K runtime plugin, and maybe we do dynamic library, and we'll call this plugin library, right? And that should have just included platform. Yeah, okay. So this is going to be brief the dynamically loaded library for the plugin. Okay, so we have that. And so I guess the next thing that we're going to start is we want to actually set up a K runtime plugin. We're going to call this new plugin. And we'll just start by zeroing that out, right? And then we'll do the address of new plugin, plugin library. right? And so if we fail to load this, then we're gonna bleat about it. We're gonna say failed to load library for plugin, and we'll spit out the name. See logs for details. And that's because if this fails, this process will have already also put out some information, right? So we're going to put the name in there and then return false in that scenario. All right, so dynamic library load function. So this is actually where we start loading up the functions for the plugin itself. Dynamic, yeah. I should name something dynamic. I do that all the time because of DNS next to each other, and I'm always like hitting the wrong key. No terminal renderer plugin on the to-do list. Actually, I have something. Actually, did I add that to the to-do list? Because I actually have. So I could have swore that I had. I guess I didn't. There was one more that I need to add here, actually. Because what you said there just reminded me. So we want a headless renderer plugin. And what that basically means is that it's essentially going to be like a stub renderer. And it's going to act as if there's a renderer behind it. And it's going to allow us to run the engine without actually having a renderer stood up. So if you need to run like the engine as a server for something, you could use that, for example. Kborg things would kaput. I actually really like it. So, okay. These suggestions are hysterical. Kbleat, why you give bad plugin, and Kborg, things went kaput. I kind of want to put those in place. Part of me wants to actually add that. I don't know that I will, but it's funny. It's very funny. Let's see. Unreal Tournament 4 got canceled a while ago. When can we expect to make our own with Kohi? I mean, that would be funny, right? Something like that would probably be doable once we have physics in place, to be honest. It's not going to look as nice, at least not right away, but must be a lot simpler than GTA 7. Oh, yeah. A GTA style game would not be an easy thing to implement. That's a huge amount of work. Not even taking into account the network play, which I would never even attempt on my own. RCW, I love that one too. That's good. Okay, so we added that. Let's see. So we need plugin types. So essentially, the functions that we're going to attempt to load are all going to be matching these names here, right? So we'll have kplugin initialize, kplugin destroy, kplugin create, etc. And so we're essentially going to loop through and try to load each one of these. And if they exist, cool, we'll save them. If not, then we don't worry about it. I do want to take a quick look, though. Platform dynamic library load. Let's look at platform 132. I know they all implement this the same in the back end. It's been a while since I've looked at this code. So dynamic library load function. I want to take a look at this real quick because I think so this is literally calling get proc address, right? So if it fails, that's returns false. Okay, that makes sense. Otherwise, okay, so it doesn't try to push this unless it succeeds. Okay, all right. I just want to make sure that that was the way that actually worked. All right, so for most of these, we're not going to require that they load successfully, but there are 2 of them that are required. So one of them is going to be kplugin create, right? This absolutely has to load. So this is going to be new plugin library. You know what? Plugin library is a little bit redundant, isn't it? Let's call this. Let's call that shared library, right? Or just honestly library. Because I don't want to have to, like plugin.plugin blah 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 is kind of weird. These it kind of makes sense because I'm going to make them match. And that should help us avoid collisions, right? Naming collisions. So those I'm fine with. All right, so kplugin create is required. This should fail if it does not exist. So in that case, we will do required function kplugin create does not exist in library, and then we'll spit out the name. Oops. Plugin load failed. Oh, we're already returning false. Perfect. Okay. So that one is required. The other one that's required is the destroy, right? So destroy. Oops. Destroy. There we go. All right, so we'll load in create, then destroy first. And then required function kplugin destroy does not exist in library. Plugin load failed. Okay, so those are the only 2 that technically must exist. All of these other ones are optional hooks into the engine, right? Because we may have a plugin that does everything it needs to do in create, and that's it, right? So I think that's fine. And so for the rest of these, I'm not going to bother with a negative check. I'm going to do a positive check on them. So I'm still going to copy pasta this. But I'm going to change this to a positive check. And then, so we'll do initialize. Let's see, does this... So I think I can literally just index into the library to get the function pointer I need, right? So let's get rid of this, and let's say new plugin library. And then let's see, we have functions. And I don't know if I want to do this by index, though. I feel like this load function should probably actually return the function pointer, not just a boolean. It'd make it a lot more useful, right? And then I could still do a negative check on these and just return 0. I feel like that would be a lot more useful, though. Starting to have a nice enterprisey ring to it. Like a plugin factory. Oh, God. I mean, I laugh, but I've seen that before. On a serious note, is the plugin name mapped to a file path, and then you try to load a .so or something? Yeah. So what it basically does is it reaches into the current working directory of the application itself, and it says, hey, your plugin DLL or SO or whatever it is, right? Dylib for Mac OS. Should be, right next to it, essentially. That's the requirement we're having, at least for right now. It should exist in this directory, so go ahead and try to load that by name. And then this dynamic library load automatically appends the file extension that is needed for that platform. And technically it also adds a, a prefix if it's needed to, right? And we have ads. Color attachments. I actually had attachments in a scene at one point. I wound up having to kill that because it was ridiculous. Completely dingus-oriented programming right there. Hundo P, what that was. That's why you bring it up so often, yeah. It's part of coding live, right? You don't always necessarily see everything that you've done like a dingus. At least not right away. Just got about 45 seconds left on ads, and then we can continue. All right, I think ads are just about done. Watching your own VOD, what is that dingus doing? Oh wait, that's me. Yeah, exactly. Yeah, we all do it. I've written some absurd variable names. So have I. I used to put like really bad stuff as temporary variable names. So that I would know like in debugging code to like remove it before I shipped it. And then I once accidentally shipped some of those things, and some of which was output to logs. I shipped some of that to production once. Learned the hard way to never do that. Never put like a variable called like bullshit in there or something, because I guarantee you will ship it one day. Learn that lesson the hard way. Okay. All right, so I think I'm going to change how dynamic library load function works. Or maybe I'll just add a new one that sort of calls this under the hood, but then returns the function pointer. Maybe that's what I'll do. So let's go to definition on this guy. And let's create... I don't necessarily want to break this, right? Although... Screw it. I'm going to break it. So we're going to do a pointer to the loaded function if it exists. Otherwise, 0/null. Okay. And that's going to break things. And I'm just going to have to be okay with that. All right, so that means I'll have to slightly change this stuff up, which is fine. So, because I wasn't actually getting this anyways. So let's do new plugin. We'll do, oh wait, we don't save off create in this case. So in this case, it actually doesn't matter. So in this case, I can leave it note, but I still have to call it though. I still have to call it. Okay, so let's do pfn k runtime plugin create equals, and then let's take that, right? We're going to say it's equal to that, and we'll say if not plugin create, then we'll do that. Did I get that right? I don't know. I feel like I didn't. Oh. Missing some. Wait, what did it do? There we go. Okay. So if not plugin create, then it fails, right? So we're not going to save off plugin create any further than this. We're just going to call it at the very end of this sequence of events. The rest of these we actually have to save. So we'll have to do new plugin dot, in this case, destroy, or plugin destroy is equal to that, right? And then we'll do if not new plugin destroy. Then we'll bleat about that one. That's the last one we're going to bleat about. So in this case, it's going to be new plugin, and this one's going to be initialize is equal to all that stuff, right? And so if it loads a null pointer, that's fine. Just reminds me, I actually changed the function signature, but I didn't actually change the implementation of it. Load function. This should be a void pointer. And we're going to do return 0 for these guys. And then this one, we're going to return f address, right? And I suppose we could just cast that to a void pointer to be sure, right? We'll have to do that again, like I mentioned, for the other platforms as well, but that'll at least kind of get us there, right? All right, so this is essentially how we're going to do it. We'll say load optional hook functions. And let's see, we have update, frame, prepare, render, and on to window resize. So we need 4 more. And this is going to be update, this one's going to be, I'll change these first, I guess. Frame, prepare. We'll do render, and then on window resize. All right, so we'll do that one. This one is render. Oops. Okay, plugin render. Okay, plugin initialize. Okay. So now we have those potentially loaded. And now what we'll do is create actually gives us a Boolean as a result. So we'll go ahead and call if plugin if not plugin create, rather. Right, and we'll just call that, and what does that want for the, I think it just wants the plugin itself. Yeah, it does. So we'll pass the address of plugin create, or wait, no, not plugin create, new plugin. Right, so if that fails, then we'll just say failed to, I guess, let's do plugin create call failed for plugin. And, oops. Spit out the name of it. Plugin load failed. And return false. Alright. So, undeclared function plugin create. What do you mean? It's right here, you dingus. What do you mean? It's no information available. What? Oh, I'm not even getting IntelliSense for that. Do I have... I do have plugin types. I'm not sure. Oh, wait a minute. That's why. Dang, missing semicolon. All right. So this is checking for the existence of plugin create. This is actually invoking it. Plugin creation. So plugin creation is going to be very, very different from plugin initialization, which will happen later in the engine. Okay. So I think that's everything we need to do for the actual plugin itself. So I think at this point we can return true. And I guess we can go ahead and just do like a k info. And we'll say plugin successfully loaded. Just to get a little more information there. All right, so now we have a way to actually load plugins by name. We actually need to save that plugin off, right? Because we haven't really done that yet. So if we get all the way down here, then we need to do what is it? State plugins. We need to do a darray push on that. So darray push. And we're going to do new plugin. Right, so register the plugin. Perfect. All right. And then from there, I think we should have everything we need. So I do want to take a quick look at this because we have this plugin create, and then we also do this plugin create here. And I want to see what this is doing. I think this is literally just calling this plugin create that exists there. So Okay. So it doesn't look like this is doing anything special with that. And I don't think this is actually doing anything special with this either. It's literally just doing the same thing. Okay, so these two could effectively be removed. Initialize application. Oh, this is for the hot reloading of the testbed library. Okay, so we can actually do... I'm going to comment this stuff out. Actually, I didn't go quite far up enough with that, I don't think. That's going to be all this stuff, actually. We can turn all that off for now. Because that's no longer going to be the responsibility of the application. Now, something to bear in mind is create application. If we take a look at the, let's see, create application. I think that was actually loaded in here as well, I want to say. Application boot, application initialize. I think this one is also externally called. Oh, right, we externed that. That's what it was. Okay. That's probably fine to leave as is. Okay. Some of this stuff has literally not changed in over a year. Let's see. Back at my first job, I did push some very vulgar variable names in production as well. Nice. I feel like a lot of us have done that at some point. As long as it wasn't about the CEO. Your boss was not too happy. This code is complete shit. Yeah. Mine, I think, just like spammed, like if it fell into a certain error scenario, it spammed bullshit to the console a bunch of times. Without any context as to where it came from. If I remember correctly, but that was a long time ago. And I actually got a call from one of the clients like, hey, I just noticed that, our console is getting a lot of logs in there that just says bullshit repeatedly. Like, do you know anything about that? It's funny to think about those things now, but yeah, scared shitless back then. Yeah, exactly. Same here. Yep. Agreed. 100%. All right. So I guess we can tie in our plugin system. The only thing I'm trying to think of where we actually want to do is where we actually do this, right? Which might actually be handled in the plugin system itself, I'm thinking. Because I did notice that none of these plugins actually have configuration that they take. At least not at that level. So we don't want the application to do it. But I think we want the application maybe to take or to provide names of plugins that it wants to use. And so I'm thinking it might need to provide, maybe what we should do, and this is just me brainstorming, right? So we might do this, we might not do this. I'm just thinking a little bit long term. So like maybe we have this thing called app config, right? That's a file. And in that we have plugins. right? Like an array of plugins. And then each one of those would have like a name, right? So it'd be like kohi dot plugin dot renderer, if I can spell it, dot Vulkan, right? And then it might have config, which has got other properties, right? And then we might have, another one that's name is, kohi dot plugin dot audio dot open al. And maybe that one also has a config, right? Or maybe it doesn't, whatever. Right? And so like maybe we can like have all of our app config look like this. And then when we go to stand up a plugin, right? We're going to load a plugin. We say, well, okay, grab the name property. That's the name. And then the config property. Well, maybe let's just take that config property and serialize it to a string or something. And then feed that in. So we could do it all in one file like this. Or we could do it in separate files per plugin. Not 100% sure which way I want to go with that, right? Run in silence. Thank you for the follow. Appreciate that. Welcome. But that's more or less what I'm kind of leaning towards as far as plugin configuration, right? Because this actually completely takes the need away for the application to code its plugins and, what plugins it uses and how it wants to set them up. Should have turned it back on them. That's our end user license agreement violation detection system going off. Ooh, that would have been good. kohi.plugin.bs spammer. Might have to make that. Might have to make that as like an Easter egg plugin or something. Now that I'm thinking about it, I kind of like this. The way that this is set up, right? Because like we could do other things in our app config as part of this, right? So maybe we have like Windows, right? Like startup Windows, and then we'll have one that's like resolution equals 1280 720, right? And that's like a vector 2. Position equals 100 100 or whatever. You have an odd number of bits so they don't work. Oh no, bits not sending. Weird. That is weird. I appreciate the effort though. Damn, and dingus spammer is more fitting. I mean, we could do that too. Or who knows, maybe somebody in the community could contribute one. That'll be a good test of the plugin system, right? Hey Josh, how's it going over on the YouTube side? The refactoring's going pretty good. We are standardizing our plugin loading as part of the refactoring. Because one thing we wanted to do was get rid of like a bunch of this kind of logic out of our game or our application code. And we're thinking of like replacing it with an app config that looks something like this, where we can define our plugins as like an array of KSON, right? And we can get the name and the config this way. So we're just kind of playing around with some ideas of how we get from like an application creation stage, and maybe this is the way we do it, to get to, hey, we need a plugin loaded with this name, with this configuration. And that's kind of more or less what we're doing at the moment. I actually I'm kind of digging this, right? Because this will be very easy to add properties to that we can then parse on the engine side. Making it a bit more declarative. Yeah, exactly. And so I feel like, especially in the beginning, in the absence of an editor, right? Being able to configure things at an application level like this would be pretty big. Because we could also, even add other things like we could do app name equals, testbed, right? And then in the window that we spawn, which is an array, so you could technically have multiples, right? You could do name, main window, whatever. And then you could do title equals testbed main window or something like that, right? And so I'm thinking that the more I think about this, the more I actually kind of like this direction for it. Because this will add the configurability that we've been kind of looking for a while at our application level. We can parse this into an app config and then, very easily figure out what plugins we need to stand up and go from there. So I think before I go too much further on that, I think that's the direction I want to go. The first thing that we need to do is go to the engine. And we are actually going to need to go to, now that I think about it, we took all of our systems, by the way, and we moved them to engine system states, right? So we have all those from yesterday. They're just here. So I need to forward declare struct plugin system state, right? And then U64 plugin system memory requirement, and then struct plugin system state plugin system. Right, so we've got that there. And then when we load our plugins, it has to come after the memory system, and it has to come after our platform system, because our platform system does require, or our platform system is required to actually reach out and load the DLL or the dylib or the SO, right? We should probably do it after the console system as well, just because that sets up the console consumers, writes, logging, all that stuff. Probably do it after we launch the runtime, or after we report the version, so that might be useful. We can do it right here before the KVAR system, I think. Because the KVAR system does not need to be stood up before the plugin system. So it'll happen before the event system, so we'll have to bear that in mind. But like the plugin creation shouldn't really be doing much of anything other than just setting up some function pointers and allocating some state space, things like that. So let's put the plugin system here. And we'll do plugin system initialize. And we're going to pass systems plugin system memory requirement, rather. So for the states, we're just getting the memory requirement, so we pass 0, and then we don't actually have any config for it right now. So we're going to pass 0 there. And then we're going to do copy this guy. So this is going to be plugin system. It's going to be plugin system memory requirement. And then let's actually just copy this guy, put that there, but then we're going to replace its guts with this, right? Only this time we are going to pass the systems plugin system state, right? And this is going to be, oops, did not want to delete the whole line. Failed to initialize plugin system. Okay, so we have the plugin system there. Keep hitting the wrong keys. That's awesome. All right, so, oh, we have ads. A little bit late on that. Sorry about that. I'll kill the screen a little bit early. How do you map a... Wait, how do you map a main/game loop to each window, though? That's going to be interesting to figure out, right? So, and that's one of the things that we are actually going to have to handle as part of this refactor as well, right? So when we start hooking up this stuff, we're basically going to wind up having to change our back-end renderer to accept things per window in some cases. So, for example, you'll have a Vulkan surface per window. You'll have a swap chain per window, right, that deals with those surface images. And you'll obviously want to have some things like probably a depth buffer per window, right? So some of those things are tied to like the device now, and they really shouldn't be. So we'll wind up having to move some of those things and tie them to a window instead, and we'll have like an internal window state that we group those resources by. And then essentially when we're updating our renderer, we'll essentially have to do that per window, essentially. My initial thought is I may not do all of that right up front. I may start off just by passing a window in through certain API points and getting that working first, and then refactor it later to actually support multiple windows. Depends on how crazy it gets, right? Okay, so plugin system initialize. I think like our configuration for that could be parsed from app config. I'm going to put a to-do on that. Parse plugin config, whoops, plugin system config from app config. C entry.c. So this is actually it's not going to be quite this straightforward. It's actually going to have to be something like systems, right, is going to be an array of a thing. And then in that, we'll have like each system. And so like we'll have like maybe name equals plugin system or something, right? It's not etched in stone yet. And then that will have plugins in it that are going to be set up. And then this just goes back here. And then we close that off. I'm off by one here, but I suppose it doesn't really matter. All right, so all of our other systems that have like to-dos on like read this from app config or whatever, we can actually read this way too. So this is actually going to be a pretty powerful thing, I think. The only thing about the plugin system config is like we're going to wind up parsing all of this stuff. Or like the whole thing's going to be tokenized and already parsed. So like, do I want to then say, okay, we'll take the configuration for each and slam that back into a string only to reparse it later? Or do I just pass this through like as is? I don't know. I'll have to figure that out. First time chat run in silence, welcome. Would it be okay to ask a question about an older video? Sure, I'll try and answer it to the best of my ability. But shoot. Okay. So that's going to be our plugin system. So I guess what I could do... is I could sort of just put together the plugin system configuration for now. Let's see, plugin types. We do have that here. We have the plugin state. I thought we had... Did we not have config here for that? I thought we had... Oh, that's not going to be in plugin types. It's going to be in plugin system. So right now this is just sort of an opaque type. I'm going to do away with that and say let's type def that. And let's turn that into a known type. So plugin system config. And in that we are going to do I guess we'll have type def struct plugin system plugin config, right, which represents the individual config for an individual plugin at a generic level. So we'll have a plugin system plugin config. So for example, we'll have a constant string name of the plugin. That's nice and easy. And then we'll also have like, maybe this is where we store like the KSON object, right? And we'll say plugin config, and maybe we just do that. I mean, that's kind of closely coupling it to KSON, but I don't think that that's actually going to be an issue. Yeoman Rowe, thank you for the follow. Appreciate that. On the video, building the material system, I'm getting a validation error about the buffer offset being 64 and needing to be 256. Yes, so that was an issue early on in the series because the card I was programming at the time only had a offset alignment of, I think, 16. But some NVIDIA cards actually have 256. So that does get fixed later on in the series. I forget exactly where, but we do fix that. It does come up and we do fix it. I'm trying to remember exactly, like the code now looks a lot different from what you're going to see there because we've added a lot of stuff to it. I want to say I mentioned NVIDIA in here specifically somewhere, I thought. Right there. So yeah, we have the amount of bytes that are required for UBO alignment. For example, a required alignment of 256 means that the stride must be a multiple of 256. True for some NVIDIA cards. So this is something we discovered. And we did fix it. I don't recall exactly when that was fixed, though. So, yeah, you'll have to You have to excuse me for that one. I don't remember. That was quite a while ago that we fixed that. I don't know. I mean, I suppose I could dig through git commits to try and figure out when that was, but I don't know if that's going to be all that useful. Oh, okay. Actually, my git lens here tells me that this was last modified 2 years ago for video number 38. So that may... In fact, I think I can actually... It says it was actually done in this pull request, so I'll drop that. It looks like I squashed a bunch of stuff, so it's kind of a big one, but yeah, it's in there. I wish I had a better answer, but yeah, it does get fixed and reviewed in the series, for sure. All right. So... I guess what we need to do is kind of continue building this guy out, right? So, do we want to tightly couple this to that? Because each plugin is actually going to have to like deserialize its own config, because we have no way at the generic level of knowing what that configuration is going to look like, what properties it's going to have, etc., etc. So I think I'm okay with, we'll probably just take a copy of, you know, the case and object, or we'll just not ever destroy app config when we launch it, right? And we'll just keep those, you know, we'll keep that case and object around so that it can be recursed through and deserialized. I think I'm okay with that. To be serialized by the plugin itself, since it knows how this should be laid out. Right. Name of the plugin. So all plugins are going to have a name, but beyond that, we don't really know. So we have the plugin configuration, right, for each one. So we'll have plugin system, plugin config, and we're going to call this plugins, right? And that's going to be a probably, yeah, I'll use a D array for that, right? And so that's going to be the collection of configured plugins. Or actually, we should probably say plugin configs. Right, so this is the overall configuration for the plugin system, right? So I think what we'll do is sort of a test for this, separate of the case and stuff, is we'll actually go ahead and set that up manually here, right under this to-do, right? So we'll say plugin system config, plugin sys config, and we're going to zero that out, right? And then we'll say plugin sys config plugins equals the array create, and the type of that is going to be plugin system plugin config, and then we'll add our plugins to that. So I guess let's do the renderer one first. So I guess we'll do let's do that. Oops. So we'll say this, and then we'll say render plugin config, or I guess we'll just say, yeah, that's fine. Zero that out. And the name of it for right now is just going to be kohi dot plugin dot renderer dot Vulkan. And so we'll basically just follow this pattern for the other plugins. So we'll do audio next. Audio plugin. That imports something. It should not have. All right, and this is going to be audio OpenAL. And then one last one is going to be the standard UI. Right, it's going to be, I'll just call this UI plugin config, and we'll do UI standard, right? And then for each one of these, we'll do a darray push, and that's going to be plugin sys config plugins, and the value here is going to be render plugin config. And we'll take a copy of that, put one here, put one here, and we want audio plugin config and UI plugin config. Right, so we push all of those. Then we can pass the address of plugin sysconfig and one more time there, right? So we're sort of hard coding this now. We don't also have the case and object filled out for these, so we may or may not do that manually. I may not take it that far. We'll see. See where we wind up. Okay. With all that said, though, I think this is probably as far as we're going to make it tonight, just because I do have to get up early for work tomorrow. So I can't go any later, unfortunately. But, you know, we made some pretty good progress today. And just to show that, actually, this is all the stuff that's been changed today. Good Lord. It's a few things, right? So our refactoring is definitely coming along, right? More than likely, I'm actually hoping that this will all be, like this refactor stuff will be mostly done by next week, so we can actually move on from this, right? But it is something we've been needing to do and we've been putting off, and I didn't want to add another system before doing it, right? So I'm going to do git add. Git commits work in progress reorg, but also plugin system, and then registry, which we actually didn't go into tonight, but we'll go into that at some point. I actually created a registry for the registration of external systems to track that. But for now, let's just push that. Right, so at least it's there on the feature reorg branch. Obviously, it's still hideously broken. But at least the current code is out there for you guys if you are interested in it. All right, so as we tie up here for the evening, I really appreciate you guys being here. on both sides, on the YouTube and the Twitch side. I really appreciate you guys being here. If you haven't already, I would greatly appreciate a follow and or a subscription over on the YouTube side. Those things help me out quite a lot to grow the channel. Right, I'm trying to reach more people, and so every little bit like that definitely helps me out. I'll also dump my socials here. If you guys are interested in any of that stuff, I've got a link tree for all that stuff. If you're interested in that, let me find somebody to raid. Let's see. Okay. Let's see. I'm actually going to follow, or I'm going to raid rather, CM Griffing. Chris is another developer here on Twitch. He's a pretty cool dude. I'm not sure what he's working on at the moment, but he's always got interesting stuff he's working on. So we're going to raid his channel tonight, and over on the YouTube side, I'll drop you guys a link here in just a second. But thank you guys so much for being here. I appreciate you guys, and we will see you guys on the next stream. See ya. Well, would help to actually start the raid. Okay. Now I will see you guys on the next one. See you guys later.